Imagine a dancer poised between two steps. If you clap sharply, again and again, just as the heel lifts, the dancer keeps resetting, ever quite leaving the floor. But change the rhythm of your claps, and the dancer moves sooner than they would alone. In the quantum world, attention itself can freeze motion or hasten it. Tonight, we learn to look without breaking, sometimes even to guide with a feather touch. If you're following this, you already think like an experimentalist. Well done. Start with a simple question. Can careful watching stop a change from happening? In quantum mechanics, the answer can be yes. If we make sharp, frequent checks, true decisive questions, the system keeps snapping back to where it was. This is the Quantum Zeno effect. Many precise glances hold a state in place, like a metronome that restarts the bar before the melody can wander. But nature is subtler than a single trick. If we alter how and when we look, change the timing, soften the coupling, tune the environment, our attention can speed the change instead. That is the anti-Zeno effect. With the right cadence, watching helps the dancer take the next step. Why does this matter? Because delicate quantum states, the kind we need for sensors and computers, are forever tempted to drift. Zeno-style checks can stabilize them, hold an excited atom longer, keep a qubit from slipping. Anti-Zeno timing can accelerate transitions we actually want, like nudging a system into a useful state on command. The lesson is practical and human. Attention is not neutral. Its tempo and texture reshape what unfolds. If you've ever improved something by checking in often but lightly, then you already understand the Zeno playbook. Projective measurements, the loud questions, give crisp answers but end the dance. Weak measurements are different, or whispers. We couple so gently that a single reading is murky and barely disturbs the system at all. On its own, one whisper tells you little. But many such whispers, carefully combined, reveal patterns with astonishing clarity, while the system keeps gliding. With this feather touch, we can map a quantum state's tendencies, track tiny shifts in beams and phases, and even boost minuscule signals that would hide from bolder probes. Sometimes these gentle techniques produce weak values, averages that sit outside the usual range. Not because the world is cheating, but because we've asked a question in a very particular way. Prepare here, post-select there, and let the faint middle accumulate. It is less a paradox than a magnifying lens forged from statistics and restraint. Why use such care? Because fragile things, from single photons to superconducting qubits, break when handled with heavy hands. Weak measurement lets us learn without smashing, refine without ruining. It's how we weigh a whisper, not with one shout, but with a chorus of quiet listens. If patience is your strength, then this is your superpower. Stacking gentle evidence until truth emerges. That instinct serves science and people remarkably well. There is a third way to look. Not a single decisive question, not a series of feather-touch peaks that we average later, but a continuous listen, a stream of information that updates our best guess of the system's state in real time. Do this, and you can watch a quantum system trace a trajectory through possibility. A wandering path shaped by both its inner dynamics and your steady observation. With continuous monitoring, we become navigators. Each moment's data nudges our estimate. Each estimate informs the next nudge. Add feedback, tiny, timely pushes based on what we just learned, and we can steer. Keep a qubit aligned, calm a noisy oscillation, hold a fragile superposition on course against the gusts of randomness. This is measurement as a control knob, not a wrecking ball. It's the difference between slamming the brakes once and keeping a steady hand on the wheel. Engineers use it to stabilize quantum devices, cool motion with information, and catch errors as they bud rather than after they bloom. If you've ever guided a conversation with kindness, listening continuously, adjusting gently, you know this art already. The quantum version simply writes it into hardware. Push these ideas into many body systems, circuits where qubits are entangling, scrambling, and evolving, and a fresh phenomenon appears. The rate at which you measure can trigger a phase transition in the pattern of entanglement. Measure too little, and entanglement sprawls. Information weaves across the system, complexity grows like a vine. Measure too often, an entanglement shrivels. Threads are cut faster than they can form. The system becomes simple, local, almost classical. There is a threshold in between, sweet spot where richness survives yet remains readable. Cross it. And the very character of the many body state changes, not because of heat or pressure, but because of how much you look. This is profound. It says that information flow itself, what is copied, what is left unrecorded, can define phases of matter. For near-term quantum processors, it's a map. Probe enough to guide and learn. Not so much that you erase what you hope to use. Curate and you create. Here's a pocket guide you can carry into any quantum lab or any delicate task. Zeno glance, frequent decisive checks can freeze unwanted change. Anti-Zeno timing. The right cadence can speed a transition you desire. Weak peak. Ultra-gentle repeated looks reveal trends without wrecking the state. Continuous listen plus feedback. Steer in real time. Stabilize instead of stop. Measurement budget. In complex systems. Set a probing rate that preserves the entanglement you need while delivering the information you require. These aren't just tricks, they're a philosophy of care. Look with intention, and you will change less than you break, more than you fear. We began with a dancer and a clap. We end with a toolkit for grace. Freeze when needed, hasten when helpful, listen continuously. And choose a probing rhythm that lets complexity breathe. In the quantum age, the way we look is part of the law we live under. How we look decides what survives. Measurement can guide, not just end. You've just mastered some of the gentlest tools in the quantum workshop. Most people never reach this chapter. You did. In the next part, we put these tools to work, turning careful looks into clocks that define our seconds, sensors that weigh gravity's whisper, secure messages that tattle on eavesdroppers, and even computers that compute by measuring.